The setup for reflux begins by pouring the components of the solution to be refluxed into a round bottom flask with 1 to 3 boiling chips. You then secure the round bottom flask on a stand with a clamp. A pad is put on an iron ring that is located underneath the round bottom flask. The pad should be close to the bottom of the flask, but with a slight space left between the two. The bottom glass joint of a reflux condenser is slightly greased and inserted into the top of the round bottom flask. The condenser is steadied by a loose clamp that is not fastened like the one for the round bottom flask. This is because if it is fastened and the round bottom flask moves down, there is potential for the seal between the condenser and the round bottom flask to be broken and release vapors. By not fastening it, the seal is held due to gravity, and the condenser would move with the round bottom flask if it were to be lowered. This prevents the vapors from being released, allowing the reaction to proceed as intended. The condenser has two side arms that connect to tubing that allow the flow of water. Water enters from the bottom arm and exits the top arm to ensure the condenser is full with flowing water.
To prevent the inhalation of hydrogen bromide, we make a hydrogen bromide trap. We do this by lightly greasing the upper part of a 2440 ground glass stopper and inserting it into the upper joint of a vacuum takeoff adapter secured by lab film. We slightly grease the lower part of the ground glass joint of the vacuum takeoff adapter and put it on the upper joint of the reflux condenser. Rubber tubing is then attached to the side arm of the vacuum takeoff adapter and to the stem of a liquid funnel. The liquid funnel is then placed in a beaker with aqueous sodium hydroxide and submerged to a depth of 1 to 2 millimeters. As pressure builds from the vapors, hydrogen bromide fumes go through the liquid funnel and are then neutralized by the basic sodium hydroxide. Where does the hydrogen bromide come from, you may ask? Hydrogen bromide is difficult to use as it is a gas. Therefore, we use sodium bromide, which is found in solid form and is a salt of hydrogen bromide. To generate the hydrogen bromide, we mix the sodium bromide with a strong acid such as sulfuric acid to protonate the salt. Hydrogen bromide is being generated in situ, which means right in the mixture during the reaction. Reflux is used in a situation where liquids are retained for the entire reaction. Heat is continuously applied to a reaction at the boiling point of the lowest boiling reagent or solvent. This allows the liquid to be retained and not lost. The vapor rises above the boiling liquid, condenses, and falls back into the boiling liquid.